Okay, next question. Predict the configuration of this structure. Now this is very important questions. We have to predict R or S configuration. So let me give some information regarding this. This is called the configuration. In old configurations, normally what was used, say for example glyceraldehyde, HOH, CH2OH. So this is called the D-glyceraldehyde. D-glyceraldehyde. This mirror image will be OH, H, CHO, then this is CH2OH. This is called L-glyceraldehyde. Kindly follow. This is D-glyceraldehyde, this is L-glyceraldehyde, common name. The convention is, if there is only one carbon atom, you take the one. If more number of carbon atom, you have to take the lowermost. And in the lowermost hydrocarbon, horizontal group, consider, this is vertical, CHO, the carbon chain will be vertical according to Fisher, the horizontal groups will be this way. If any electronegative atom or group on right hand side, D. Any group or any electronegative atom or group on left hand side, L. This is the configuration. So D-glyceraldehyde, L-glyceraldehyde, D-glucose, L-glucose, D-lactic acid, L-lactic acid, D-tartaric acid, L-tartaric acid, like that we can. But the problem is, when you go for tartaric acid, the system fails. So for example, let me give a simple example, tartaric acid. You take now HOH, now OH, H, COH. This is one tartaric acid structure. The another tartaric acid you will write now. This is H, OH, COH, and this is COH. Kindly follow. According to the rule, lowermost, both are D. But just look at the structure, they are not same. This is mesotartaric acid. This is optically active tartaric acid. It may be plus or it may be minus. So they are different, but unfortunately the D and the L system fails in the case of mesotartaric acid. So that's why Kahn, Ingold and Pillock introduced a system called RS configuration. So that we must know first to assign RRS configuration. So it will take a few minutes. So kindly follow me. Let me design now. What is the condition to show optical activity first? To produce a non-superimposable mirror image, a molecule should have. That means all optical activity, it should produce a non-superimposable mirror image. To produce a non-superimposable mirror image, a molecule should have no plane of symmetry, no center of symmetry, no axis of symmetry, and no alternate axis of symmetry. If you rise secondary level, you can take only plane of symmetry. What is plane of symmetry? A plane of symmetry is one which bisects a molecule into two equal halves, so that one half will be the mirror image of the other. That is the plane of symmetry. Now I have indicated by sigma. Next one. So here I can further classify into three types. One is vertical plane of symmetry, sigma V, horizontal plane of symmetry, sigma X, diagonal plane of symmetry, sigma D. All these planes are present in benzene ring. Kindly follow. This is vertical plane, this is horizontal, this is diagonal. So when there is a diagonal plane or vertical plane or horizontal plane, the molecule is optically inactive. So absence of symmetry is most important. This is the conditions. So center of symmetry, again not necessary for your secondary. Anyhow, center means you can start from one atom, move towards the center, and if you move opposite side, again same atom, that molecule have a center of symmetry. Any molecule is having center of symmetry, if you represent by I, it is optically inactive. The next one. Now let me come for optical activity due to asymmetry. So optical activity arises by two ways. One is due to asymmetry, another is due to dissymmetry. Asymmetry means there will be four different atom or group present in the carbon atom. Disymmetry means there is no asymmetric carbon, and molecule as such will be asymmetric. That is allenes, spirates, biphenyls are example. So let me concentrate on asymmetric carbon atom. Asymmetric carbon atom is one where 4 different atoms or groups are attached. Suppose you take D-lactic acid, and you follow old convention. I am using this because D means OH on the right hand side. Now 4 different groups. So I can say optical activity due to one asymmetric carbon, optical activity due to more than one asymmetric carbon. I have to first find out. If it is one asymmetric carbon, specific example lactic acid, so I can get a mirror image. D-lactic acid, this is L-lactic acid. So if there is only one asymmetric carbon atom, there are two forms, and these 2 forms are called enantiomers. Kindly follow. Plus and minus forms are called enantiomers. So, okay. Optical active compound having same molecular formula, but one will be the mirror image of the other, are called enantiomers. Example, D-lactic acid and L plus lactic acid. So now we will come for R&S system of configuration. This is the most important for determination of R&S configuration. What is R&S? Cone-Ingold paradox rule. There are 2 rules, sub-rules. One is sequence rule or priority rule, another is conversion rule or chirality rule. The sequence rule gives inferiority or priority inferiority. We have to give atom or group for 1, 2, 3, 4 based on atomic number. The conversion rule we have to view now, calculating the 4th priority, we have to view through 1, 2, 3. If it 1, 2, 3 moves clockwise or 1, 2, 3 moves anti-clockwise, yes, in the case of model. But in the case of board, we have to follow different techniques. So sequence rule, arrange the atom or group present in the asymmetric carbon atom, the order of decreasing atomic number, A, B, C and D are 1, 2, 3 and 4 according to the sequence rule given below. What are the sequence rule says? When 2 or more groups of identical first atom attached to asymmetric carbon atom, the priority order is determined by considering the next atomic numbers of second, third atom. So until the priority order is fixed. Say for example, in this case, OH is number 1. When come for CH3 and CH2O, CC common, 2 hydrogen common, and thirdly, here hydrogen and below OH. So these take second priority, this take third priority, this is the 4th priority. So the rule, first rule, this is the rule. Okay, next one. When you are giving the number priority, some rules you have to follow. A double or triple bond is considered as equal to 2 or 3 single bonds when you are assigning priority number. C double bond C equal to CC. CC you have to consider. C double bond C is considered as C bond C, C bond C, C bond C. You have to consider. Example in this case, so here CHOH should be considered like this, and CHO you have to consider like this. Okay, then. Next one, higher atomic mass precedes lower atomic mass. Suppose atomic mass or atomic number is same, but atomic mass is different, you should be careful. Say for example, as usual, number 1. Number 2, both all the 3 atomic numbers same, but mass is, this is number 2, this is number 3, this is number 4. So that means tritium is greater than deuterium, greater than protium. So atomic mass takes priority. Then the same way, cis group precedes trans group. That means this is, if there is cis and if there is a trans as one of the group present there, cis takes priority over trans. Same way, Z group takes priority E. And lastly, R group takes priority S group. The next one. So, once the order is fixed, then we have to assign convert the order R or S. For that, once the priority order of atom or group is considered, the configurational assignment is made by applying the chirality rule. In the case of the dimensional model, the molecule should be viewed from the side removed from DR for the lowest priority. Kindly follow, this is based on model. Only if you have a model, if A, B and C are now traced right-handed turn clockwise, then configuration is R. where R stands for rectus, a Latin word meaning right. If A, B and C now traces left-handed turn anti-clockwise, then configuration S, where S stands for sinister, a Latin word meaning left. So this is the most important factor you must come across. Okay, now how to predict the configuration for this one? So here what I have to do here, kindly follow, I am giving one more information. The rule is, this is, kindly follow me. So let me take this example and I will write, you can follow. That means first give priority, this is number 1, chlorine number 1, OH number 2, CS3 number 3, this is number 4. Okay, we are fixed. And kindly follow, if you draw 1, 2, 3, it moves R. R is the actual value, but here right answer given is yes. How, what is the controversy? Because the rule is applicable only for model. But if it is applicable for two-dimensional, now Fisher has given a very good guidance. So we have to put plus, and then this is called vertical groups and this is called horizontal groups. So now we can say, I can give you, if the fourth priority present in the vertical groups, whatever you predict is correct. This is for applicable for two-dimensional board or notebook. Let me repeat again. Consider the foot once after writing the arrow, predict RRS. And look for the fourth priority. If the fourth priority is the vertical, then it is right. If it is in the horizontal, the predicted is wrong. A reverse is correct. So according to this is on the horizontal. So what I have predicted are, so reverse yes is the correct answer. So answer is yes. Kindly follow. There are number of methods available if you go for M.Sc level, 4 or 5 methods. This is the method I have developed under a published paper on the Indian Journal of Chemistry.